Hello. In this exercise, I'm going to show you how to create the PAWL, P-A-W-L, on page 21 in the Interpreting Engineering Drawings textbook. I'm in the 8th edition, page 21, working on the PAWL. The units are millimeters, grams, and seconds. Your ANSI drafting should be set to ANSI. You might have to switch out of ISO, go back into ANSI, and the material is plain carbon steel. But at this point, all of these things should be okay with everyone. What plane do we start on? I'm going to say the top plane. Not that it makes a difference for this flat part, but the top plane or right plane would have been okay. But I'm sketching on the top plane. And I need to make a decision as to where my origin is going to be. And it looks like the best location would be in the center of that 25 millimeter circle. So I'm going to start with that. And if for some reason it doesn't work out, it's okay. I can always alter the origin's location by moving the geometry, or I haven't done much of anything yet, so I could just start over. But let's start with the 25 millimeter circle. And now I just kind of have to draw the entire shape around this circle. And for this instance, I'm going to use the line to tangent arc technique. And I'm going to start right about here, below the origin, but like to the right. Then I'm going to draw a line over some distance. It doesn't matter really how far. I'm going to come up. I'm going to come over to about right about here. And instead of clicking a line, I want to be in the arc command. I don't want to draw another line. So I'm just going to bring my cursor back over to where I ended, and it will transition me into a tangent arc, which is really sweet. It may take you a few tries to get that right, but now I'm going to draw a nice arc right about here, and then it transitions back into line, but I don't want a line up here. I want another arc, so I have to bring my cursor over again to get that arc, and that takes a little bit of practice to get that just right. Then I'm going to come down here and draw a straight line to make a sharp intersection, and I'll explain why I didn't use the tangent arc technique. I come down a little bit. I'm going to come over, and again, I'm going to leave this point sharp. I'm going to zoom in so you can see what I'm doing, but I haven't exited out of the line command. Not yet. I'm going to come over here, and now I'll transition to a tangent arc because I want that outer arc, and then I'm going to come straight up to a sharp intersection. So I'm going to pause for a second. I'm going to move this out of the way. But what you can see is I've got the generic shape drawn, and I've left this fillet out and this fillet out because I want to use the fillet command, which is a lot easier, and I'm going to do that right away. So I'm going to click Sketch Fillet, and I'm going to punch in 15 millimeters because that's the radius. At least here it is. And one here. So I could do two of those at the same time. And that is why I waited and drew them sharp in advance, because it's so much easier to use the fillet command. But in this case, there was nothing to fillet, so I just drew the arc. There was nothing here to fillet, although I could have drawn these lines square now that I think about it. But I think transitioning from the arc into the next tangent arc was beneficial. And let's put one more fillet right about here. And this fillet's a little different. This one's 25. And we'll put that right at that intersection. So now I have my 25 radius. I have the 25 through hole. I have this 15, and there is a circular cutout here and another here, but I don't want to incorporate those just yet. I want to get the shape of this thing done because it's completely underdefined. So let's try this radius. That one's going to be 15. This one's also 15. I could add an equal relation, but I'm going to duplicate the dimension for now, and then maybe I'll go back and switch it after. We'll make this one 60. This distance is 25. And you'll notice that the geometry will start to move as I fill in my dimensions because the geometry is conforming to whatever I put for a dimension. So I made this 25, but I never told this to be 25. So I could come in here and say, well, I want the length of this line to be equal to the length of that line. And now this geometry shifts down and it matches the right side. And don't be afraid to move geometry. Remember, if you have blue geometry, it can move and flex. Sometimes moving geometry will tell you exactly what it is you're missing. Now I'm missing a dimension from center to center of the arcs, and that is going to be 110. All right. And let's see what else we're missing. So from here to here, so from the center of the part to this flange is going to be 15. So that kind of locked that down pretty good. And I see a relationship that we need to add. So this point, and this point all must be vertical with one another. So I'm going to go ahead and add that relation between all 3 points, and I'm going to say vertical. And that shifted the arcs over and gave them a home. But we still have a lot of underdefined geometry. So let's see. What are we missing? The overall length of 215. I never added that, so that's definitely something we need. And now let's see. What are we missing? Let's see. We need tangency here, so let's verify that we have tangency between the arc and the line, and we do. So that's not the issue. Let's try moving our geometry. So that's sliding left to right, which tells me that I'm missing a location. So let's stop that from shifting left to right. So a dimension from here to the left should fix that. And it's going to be, the way that the book is dimensioned is 65 plus 25. So 65 plus 25 gets me over to the left. So, lots of blue geometry. Let's find out what we're missing. So that's, so that moved a little bit. And right there at the top left should tell you that abrupt transition between the arc and the line is incorrect. So I have a feeling we need tangency here. So let's go ahead and add that. Yep, it was missing tangency. Now it's tangent. Lots of blue geometry. Let's come down here and find out why this is all blue. Oh, missing tangency again. Right here. That is not a smooth transition. So let me click Add Relation. I'll click the arc and the line, and I'll say Tangent. That fixes that, but it's still underdefined. Let's see. This can move. I don't want it to go down there, and I don't want it to go too high, so we're missing a dimensional, a dimension to prevent it from moving. So, and here it is right here. This one's probably the trickiest one to pick up, but these 2 points need to be horizontal. This 60 is a quarter of a circle, and I don't have that yet. Once I force these 2 points to become horizontal, now I have a quarter of a circle, and I'll show you what I mean by that. I'll just use a center line to show you, but now this is a quarter of a circle. So if I were to draw the complete circle, it would look like this. All right, so this was a fussy sketch. If you didn't get it right the first time, there was a lot of relations, and I just showed you more or less the hardest way to complete this. A simpler way would be to start with a rectangle, so maybe from here to here, and then extrude that, and then draw another rectangle and then fill at the end. Draw another rectangle and fill at that end, and then cut out the circle last. There's other ways to do this. Multiple features and multiple sketches, but much simpler. This was all done in one shot, minus the cutout here and the cutout there, but I'm gonna do those separately. So I'm gonna extrude this to a thickness of 10 millimeters. Make sure I don't have a negative sign, which I don't. And then I'm going to draw a new sketch on the front surface of the part, or the top surface rather, and dimension those 2 cutouts. So one right about there, another one over here somewhere. I'm going to make both circles equal and dimension their locations. And their diameter. So the book gives a radius of 10, which means our diameter would be 20. I'm going to revert back to my isometric view. I'm going to click Features, Extrude Cut, Through All. Make sure you pay attention to the direction of your cut, because if it was cutting upward, it would fail, because it's cutting into thin air. So you have to make sure that it faces the correct direction before you exit out of Cut Extrude. So 2 sketches, 2 features. Let's find out how much this thing is supposed to weigh. So I'm going to click the Evaluate tab, Mass Properties, and if you've done it right, the PAWL on page 21 using metric units should weigh 688.75 grams. So 688.75 grams. And that is how you complete, or at least one way to complete the PAWL on page 21. I hope that helps.